Hello guys, I am Prajit Shah from Team Nekoma and this is our submission for Afourathon Hackathon. So our problem statement is library student details application. It is done with my teammates Sanika Hardekar and Rachna Yalli. So moving on to our problem statement. So the problem statement states to create an library student details application. So our primary aim here was to provide a safe and secure platform for college library staff to perform the CRUD operations for student details and manage their library portal. We have achieved this via a robust application which is not only secure but it is efficient and easy to use and manage all the details of students, and it can be run on a container on cloud using Docker. Are reasons to select this problem statement. So, through intense brainstorming, we came to the conclusion that currently available applications for similar functions have been confusing since they have very intimidating user interface which can be improved. This is a sense of relatability for students and their day-to-day study preparations. It has a vast scope for innovative ideas and there are varied use cases which can be performed by adding more features on top of the existing solution. We can use multiple technologies here to diversify the development process and create a solution which works the best possible way. We want to make the most of the available resources to develop a top level product which is production ready. So the technology used in our solution is React.js for front end of the website. We have used Flask for the backend as it is a monolithic architecture and follows a three-tier architecture with React acting as the GUI for manipulation of the database. Flask we have used Flask to create the microservices in backend following a monolithic architecture. For we have used pandas for Excel manipulation inside our backend. So we have why we have used this would be easily clear when I move on to the demo. We have used SQLite with SQLchemy database. So the reason to go with SQL database here instead of the NoSQL database is that the data of students is in a structured format and there is no need to increase the memory required to store these data in an unstructured format in a NoSQL database like MongoDB or so. As the current users and the amount of data is less, SQLite performs really well. And if we want, when the user base increases, we can shift it to Postgres database whenever we want to. We have used Docker for containerization of our front end, which can be run on any local device through Docker. We have used Git and GitHub for version controlling, and we have done various branching and testing features there. So, moving on to some of the features of our application. It comes with a secure authentication. It has an admin only site which has to be pre-approved by the backend server to access the site. It follows a JWT based authorization for each and every request, which makes it very secure so that only user authorized to do such actions may be able to manipulate the student details. It works on all machine exactly the same with the help of Docker containerization. It gives out relevant notifications after each operation is performed. Form validation throughout the website is done through Formic in both client and server side. Though some of the features of our app include addition of a single student. We also provide a feature of bulk addition through Excel files. So the administrator does not need to add every single student individually. He can directly upload an Excel file containing the list of all the students they want to add, and our backend processes it using the pandas which I mentioned earlier and adds them in the database. We also provide updation of a single student. We provide a table view with an intuitive UI where you can view all the students and perform various type of filtering for your clarity and more operations. We also allow deletion of student. All the notifications using snack bar from material UI are stored. Moving on to the future scope of our project. So our future scope includes integrating management of books in the application as well alongside the student details. We can also add the book lending functionality where students can log into the site and request and check for books. We can also give access to students to perform browsing of the books available in the library or available in the e-library of the application of the of the college. So moving on to the demo of our application. So first I would like to move to the backend code of the application. So this is our backend code which is written in Flask. So this is the admin table in our database which contains of ID, email, user type equal to admin and the password. We also have the student table which consists of its ID, name, email, phone number and the user type equal to student. So the basic route checks for the whether the server is up and running. Then we move on to the admin routes which are register admin. You can see the documentation here, and we have also created the API documentation which I will browse through after I complete the demonstration of my backend code. So this is the register admin route. It checks for all the possibilities and gives relevant response to each and every type of request. So it gives either 200 or 401. Then there is the login admin route, which gives the 200, 401, and 404 based on the request. It has all the exception handling in place. All the routes have exception handling so that the server does not crash mid running. And we have tried to maintain the asset properties of the database so that all things move smoothly and the database and data integrity is preserved. This is the get admins route to get all the admins available. Now this is a register single student route. This is the for bulk registration of student through an Excel file. As you can see, it takes in file as an input. It also saves the given file in the static folder. Using pandas, it processes each and every row in that Excel and adds the student individually and returns the list of messages for each and every student. This is getting all the students route. This is getting an individual student route for updation of student or deletion of student. This is the update student route. As you can see, it requires an ID. This is for the delete student route. So it also requires ID just like the update route. All the try except things are in place so that the server does not crash anytime soon. We also have the test admin file which is done using Pytest to check whether our server is up and it is working fine. I'll just run it. I'll just run the code for you. As you can see, there is a previous code run which shows that the all the test cases are passing successfully. This is for checking if server is running perfectly. Now, before moving to the DevOps part, I'll first show you the API documentation which we have created using Postman. So these are all the routes available, and each and every route can be seen here in Postman and can be run to check with the dummy parameters which I have mentioned here. It contains robust documentation of what every route does and what it requires and how each request should be sent. The speciality of Postman is that it shows the code in any language you want. So if I see using Python, then I'll see how do I request my code as well. So this can be integrated in our website as well and used to be create an SDK which can be integrated to any existing library management service as well to utilize this infrastructure of our backend and to make more features on top of it. Yeah, as you can see, delete and update our put routes and all other are get and post routes to wherever they go. So our backend currently is hosted at Python Anywhere. So all the logs, access log, error log, and server log of the website and all the APIs are mentioned here in the Python Anywhere. So they can be checked whenever if we see any discrepancy in our server. Moving on to the DevOps part now. So we have used Docker container. This is the Docker file which we have created to store our application on the Docker app. But the backend is currently hosted on Python anywhere, so we are not hosting the backend through Docker. Backend is hosted through Python anywhere, and the frontend is hosted through Docker. Now moving on to the frontend part. So the frontend is created in React, and we are using the Docker compose up command to run all our file. As you can see, this is the Docker file and the Docker compose file. I will move on to the front-end application of this code as well. So I have pushed this container on the Docker hub, so you can see this container here. I've also provided a README to see how to run this service on your local machine. So only thing to need is to turn on the Docker desktop app and go to this and just run this command on your terminal. I will just show you. Then your front end application would run on the localhost 8080. So as you can see, I would mention any not image name, container name here. Suppose trial. So yeah, it will show me an output and it will start running. Yeah, so it has started running. Now if we see on our Docker desktop, we can see that the trial container is up and running, and if we go to the port, we can see that our front end application is visible here, and you can perform all the operations here. Now moving on to the demonstration of our front end application. So this whole application is created in React. The code here is available on our GitHub. I'll just show you where. So this is our GitHub where we contain all the code. So this is the code for the backend. The front end code is on the front end, and the production branch of front end is deployed on front end pro. So you can also see where you can access the front end via README. We have also deployed the site if you want to check it out while evaluating the solution. You can see the deployed site here as well. But the main motive of this hackathon was to deploy it as a containerized application so that it can be run on a local machine in a library architecture software. So yeah, to ease it out for you guys, we have also deployed it on Netlify, which you can access, or you can run it directly via Docker through this command. So this is our Docker run container or image. So now I can sign up for an admin. So if I sign up gmail.com, as you can see, we have all the integrity checks available. So if you enter any invalid type of input, it would show you an error. So the minimum amount of password required has to be 6 characters. So I'll just add the password as dash@123 and I'll sign up. So once I sign up, it redirects me to the login page. It means that my application have been submitted to the backend, and I'll just log in through that signed in username and password. Yeah. So I I guess I misspelled the application. I'll just do it again. Yeah. Yeah. So as you can see, I'm able to log in onto the application now, and I can see the records available of students in our website, all records, and I can add students as well. So if I move on to the all records section, I see a pop-up which came here. I'll just come back here. I can see all the pop-up which comes here to see all the available operations. So I can see the table here which can be edited as well. I can move through the pages and see the number of students and also increase the number of pages. I can also filter the table as per my need. So I can filter it via ascending, descending, or I can add custom filters like contains, equals, starts with, so to check all the details faster and quickly. I can delete this student as if I want, so the student gets deleted. I can even update the student. So as you can see, this is the previous student. I'll just add some hyphen here, and if I update, so I can see the student updated successfully, and I can check here. So you can see that the student is updated successfully. If I try to edit a student which ID which already exists in a database, then it gives us an error saying that the student with that ID already exists. So if I try to edit this student with an ID which is already in our database, it would not allow it, and it would give us an exception saying student already exists. So such kind of integrity checks are implemented in our backend so that duplication of data is not allowed, and the data is maintained properly, and there is no indirect deletion of any records while updating any record. So here I show you the update and delete. Now I'll move on to the add students part. So as I mentioned, you can add student via a single addition of students or via uploading a CSV or an Excel file. So if I give you an student ID, suppose this is the student ID, and I'll write name as Afourathon3. All the integrity checks are available here as well, so you can do anything. So this is the phone number as well, and once I create the record, I see that student log is created, and if I view it, I see that the created student record comes here. I can also add student via an template which is available here. So as you can see, a template is available here. All I need to do is fill this template and submit that template to able to add bulk students in our record. So let's do it a simple addition. I'm adding dummy data here. As you can see, I have created this Excel file with all this dummy data, and once I upload it here, it would take in the upload and it would process, and it would say me all the bulk registrations are done. And if I view the table, I can see that all the registered students which I mentioned in my Excel file are updated and added successfully in our application. And the available Excel file also gets stored on our Python Anywhere backend. So yeah, as you can see, that file is stored here. Yeah, this file. It's the file which I just uploaded. So this is the Docker Hub container where I have hosted. I'll just stop the container. To stop the container, I can just write this on the terminal, or I can go to the Docker container and stop it here directly. So if I write docker stop prior, so my container gets stopped here. As you can see, I see an exited command here, and my website automatically stops working. If I go here, it stops working because the container is closed. Now moving on to the front end testing. So to do tests on front end, uh, we have tried using it issues where we personally did peer testing. So we checked which stuff are not working on a site correctly, and then based on those test cases we resolve those different tests. So this is the test case one which we saw was not working good. This was basically the student data integrity. So the number should be 10 digits, the string, the letter, the email name should be in the correct format, and those was the first test case. And this is the again different test cases and different type of output. So there were also some conditional issues which we were getting, so which was not routing the pages correctly, so that was also resolved. To send a request to each and every endpoint of the backend, you need to be authorized. So whenever an admin logs in, they are sent an JWT token created by the backend server, which lasts for 2 hours, and that token has to be sent with every request for accessing the data. Otherwise, it will tell me that you are not verified and you need to authorize yourself to send requests to this server. So as you can see, each and every route of the backend contains an JWT required decorator, which requests for JWT. And whenever the user logs in, they are, and if the login is successful with 200 status code, they will get the access token, and that access token is stored in the front end. So if I'll show you that. So this is the Netlify version of our application. It is also the same. So if I log in using the user I created, yeah, as you can see, I've logged in using the user I created via the Docker container application. I can see that the token is stored in my session storage. So all this token has to be sent via every request for all records and stuff to get the data. Yeah. So it is sent via request to access the data. We have also written readme to for creating the application and how to access the application as well. So the front end can be accessed through Docker or through the deployed site, or you can download the given branch using git clone and run it on your local machine as well. Those documentation is also provided by React itself, and this repository is currently private, but all the codes and the stuff would be sent via the documentation which we are creating. So we are also creating the documentation for Afourathon. So we have mentioned all the relevant uh, future scope, all the design principles which we have followed, the database design alongside the diagrams, the API documentation here as well, which you can review and let us know if there are any discrepancies in it. We have also mentioned the unit testing methods which we have followed using, and all the technology stack which we have used here. So I'll just go through again. The operating system is any operating system can be used as it is a containerized application. So the development was done using Visual Studio Code and Docker alongside Git branching. Programming languages used are JavaScript for React and Python for Flask. Version controlling was done using GitHub and Git. Package managers were npm for React and pip for Python manager. And database used was SQLite, as it is an SQL database for structured data. Development integration environment setup is also written here to run the front end of application on your local device as well. So this is us for the submission video of our project for Afourathon. So thank you for listening, and I hope you like this project.